So, hello everybody and welcome to our webinar today. Topic today are integrated traceability solutions for development of autonomous vehicles. We will hold this webinar together with ITEMIS this time. Our guest speaker is Mr. Boris Holzer. He is product manager at YAKINDU. We will get technical insights by my colleague, Mr. Ingo. His role is Senior Field Application Engineer at Vector Informatic. And my name is Winfried Schröder. I'm Business Development Manager for Vector at Vector Informatic. Sorry. Let's take a quick look at our agenda for the next hour. I will give you a short introduction and an overview of Vector's testing solutions. After this, Boris will talk about the integrated traceability solutions for development of autonomous vehicles. He will also introduce us to YAKINDU. This is followed by a tool demo from Ingo to show us how the tools work together. At the end of this webinar, we will answer your questions. Please use only the Q&A window to send your questions to the moderators. So let's start with a few words about Vector Informatic. Vector was founded more than 30 years ago in Stuttgart, Germany. Today we have more than 3,000 employees and offices in many countries in Europe, Asia, and North and South America. As you can see in this graphic, the first version of VectorCast was launched in 1992. VectorCast was initially built to test embedded applications with the highest criticality levels according to the DO 178 in the avionics industry. VectorCast supported Ada as the first programming language. In the following years, the support of C and C++ followed. Maybe you ask yourself why this is important. Well, in the recent years, VectorCast was established in many other industries besides aerospace. This is related in the functional safety standards that have found their way into all industries today. Since VectorCast was used from day one to test safety-critical embedded systems with the highest criticality in the avionics, it is also a perfect fit for all other safety and business-critical industries today too. Here you can see the V model with Vector's testing solutions. We will focus on VectorCast today. VectorCast products are located at the bottom and the right side of the V model, where all the tests take place. As you can see, VectorCast is a test solution for all phases of software testing, starting from low-level software tests to a complete system test. Testing can be performed natively on a C, on a simulator, or on the target environment. VectorCast supports hundreds of embedded compiler-target combinations, and VectorCast has integrations with many other tools you probably have already in your development environment. So how does test automation work with VectorCast? On the left-hand side, we have C or C++ source code in blue and red. VectorCast takes one or more units under test and creates automatically the test driver and steps where are no real dependencies. The result is an executable which can run on a host, a simulator, or the target environment. Not only in the development of safety-critical software, it is extremely important to know what the test process currently looks like and how it can be improved. VectorCast helps you to reduce the time it takes to test, to increase the frequency of test runs, to increase the quality of the software by enabling any developer to test these code changes immediately after the code change at any time, and to maximize the level of automation for software testing. VectorCast has features that optimizes all these areas. So that was my short introduction. It's now time for Boris and to speak about the integrated traceability solutions for development of autonomous vehicles.
Yeah, hello everybody. Welcome from my side. Give me just a chance to share my screen. So waiting for a second and going into the presentation mode. So today I want to talk about YAKINDU Traceability and the impact or challenges in traceability that we are facing today, especially in the field of autonomous driving. But first, let me tell you something about ITEMIS. We have our headquarters and base in Germany. You'll find us also in France and Switzerland and in Tunisia. And our background, we originate from, let's say, really tool improvement company with a strong focus on modeling technologies, domain-specific languages, maybe textual or graphical modeling. And we have a strong pillar in the automotive industry and embedded industry. And our palette in this field ranges from simple tool adjustments to setting up complete tool suites. And over the years, some of these solutions made their way into our YAKINDU product family. So it's not one product, it's a whole family. We have YAKINDU state chart tools, which is a tool for modeling state charts, generating codes, and high sophisticated tested on state level. We have this YAKINDU security analyst who helps you to validate the cybersecurity status, threats, and countermeasures of your project. And we have the YAKINDU model viewer, which is let's say, cheap solution if you need to look on MATLAB, Simulink, or state chart models. And we have YAKINDU Traceability, and we will look at this tool in detail. So, first I want to tell you about the challenges that we are facing, that we are experiencing together with our customers, and that we overcome with our tool, YAKINDU Traceability, and the benefits that traceability can bring in your development. And I also want to highlight the process, how we implement traceability in your organization. And I mean really the process of traceability and not the tool. And of course, I will give a live demo. So first of all, traceability challenges. So what we experience today is project complexity raises faster than our tools and methods can help you in that. So complexity raises faster than tools are capable of that complexity. And this quote is from 2013. And to my observation, the situation has aggravated since then. So the gap is widening, and the speed of this widening is getting faster. So first, what is traceability? I like this definition from the Automotive SPICE process assessment model very much for 3 reasons. First reason is simple. So if you can link work products, that's traceability. And the work product is anything, any item in your project. It may be a simple requirement or test case or test result or some data. Everything is a work product. A work estimation, a task in your ticket system, everything is work product. And if you can create references or links between these work products or artifacts, that's traceability. So first reason is it's a simple explanation. Second reason, it does not it talks about pure traceability and does not use the term requirements traceability. So each artifact in the whole V is important. If a test case failed, you want to figure out which requirements are affected. If a requirement changes, you want to see the impact of that change, which system components are affected. So traceability is something that addresses the whole V, and it is not only requirements traceability, it's really embedded systems development artifacts traceability. And the last reason this definition gives a motivation. Why should we do it? Because it's so beneficial. It helps us to master the complexity of your projects. So you can do the standard coverage and impact analysis. You can do custom analysis, which we will see during the demo. And you can even implement your implementation status tracking based on traceability data. Yeah, and so for me, the message of this definition is not traceability is a standard and you have to do it, but traceability is beneficial. It helps you to master complexity, and that is why traceability is part of so many standards. And I just mentioned a few on this slide. So, message of this slide is it helps you to master complexity. Yeah, but there are some challenges. So. Here you see the V defined in the Automotive SPICE standards. So there are quite a lot of artifact types like stakeholder requirements, which should be linked to system requirements, which should be linked to system architecture, artifacts, and so on. We have the whole test and verification artifacts on the right side of the V, and quite a lot of links. Traceability, SPICE compliant traceability is a challenge in itself, but there is more about it. So when we talk about the number of artifacts or work items in the V, when we have some prospect calls and maybe not in the field of automotive and these potential customers say our projects are real big, then sometimes most often the V has a size of 1,000 artifacts. For a typical ECU project in the automotive industry, the size of the V ranges from 20,000 to 250,000 artifacts, and we are capable to master and analyze the traceability on such projects with our tool. But when it comes to autonomous driving and artificial intelligence projects, there is another boost of the size of the V, so really tens of millions of artifacts, and this is really a challenge for the established tools. We get quotes from customers which say even our established requirements management tool does not scale. It does not give us the right answers in time. Another challenge are the tool chains. So you have specialized tools and you want to interconnect these tools. There are standards like OSLC to build such connections. This standard is not supported by each tool, and it's only helpful, let's say, in one direction. If you want to link artifacts, then OSLC is definitely a solution. But if you want to answer the question which artifacts are not yet linked, so do a coverage analysis, it's not helpful. So you have to somehow collect the data that is spread over a heterogeneous tool chain, and you have to homogenize these data. And last but not least, we have different roles and cultures in our projects. We have software developers who use different tools, but also have a different culture, like compared to hardware developers. So we have cases where hardware developers want to maintain their traceability in Excel and not use a dedicated tool, and the software developers say, "Oh, new tool, cool, let's try it out." So and we want to support each of them. So cross-domain and the whole we want to cover that, and give everyone the work environment that he needs, and we don't say use our tool and you are happy. Our point is we help you to use your tools and extract the data from there. Yeah, another challenge, especially in the field of, let's say, artificial intelligence, not only autonomous driving, is if you have a neural network and training data, and you train this neural network, where does this fit in a software SPICE-V? So here you see on the left side some code defining the neural net. If you consider the neural network to be software, then it should be a software component. So what is this definition? Is this a detailed design? And what about the learning data for this neural network? I don't see quite a place where it fits in the automotive SPICE definition of today. So maybe it's a different domain compared to software, or is it software? Can we explain neural nets? Does it make sense to specify unit tests for neural networks? So this is a challenge. I cannot give you an answer today. If you have ideas, please let me know in the comments, so in the form of question. I'm really looking forward to that. Yeah, YAKINDU Traceability. So we want to highlight and enable the benefits that motivate the definition that we saw given by Automotive SPICE. So our approach is really bring data together and analyze them smart and allow navigation across tools. So that is the offer that we give to you with YAKINDU Traceability. Yeah, first approach is we really analyze the data of various tools. So this slide shows only an excerpt of the tools that we are supporting, and we do read the data as native as possible. So for Polarion, for instance, we read the data from the database. For Enterprise Architect, we read the data from the database. For MATLAB, we pass the files ourselves, and that is because we learned that the API layers of these tools, they are too slow. We cannot analyze traceability for even in let's say in the ECU size of projects in time, because we cannot read 100,000 artifacts when we use the API layers. So we decided to really read the data as native as possible, and this results really in fast data reads. So we have projects, one of our where we can analyze the traceability in an ALM PLM system faster than the ALM PLM system itself. So because we don't access the API layer, we do this on data level. Second thing, once we have extracted the data, we define a common vocabulary for your project. So we're talking about requirements independent of tools. We're talking about unit tests independent of the tools, and we do our analysis based on that vocabulary, or not based on tool data. So if you define your coverage matrix, you define the coverage metric based on the vocabulary and not on tool attributes. Instead, we map the data from the various tools to our vocabulary. And here's an example. So we consider a requirement approved if it comes from DOORS and the approval status is set. But if the requirement comes from Word, we consider it to be approved if it's not strike-through in the Word document. So we can map attributes to our vocabulary. And for us, it does not matter whether your test is failed or not successful or has an X or a check mark. We just map the tool data to test is passed or failed, and you can then analyze tool independent the status of your data. And yeah, as I mentioned it already, you can stay in your world of tools. You don't have to import all your data into one ALM PLM tool. You can do your modeling in your modeling tool. You can engineer your requirements in your requirements management tool. We bring the data together for you. So stay in your tool. And if you want to, you can even use YAKINDU to navigate across tools. Yeah, another thing is who maintains the links. I mentioned the numbers of artifacts. The V's are really huge. Who can maintain all these links? And my answer is, when we come into the project, there are quite a lot of links. Really quite a lot of tools support bilateral linkage, and we will see that when Ingo gives the VectorCast demo. Requirements and tests, they are linked in the test tool, and we can analyze, we can read the requirements from the management tools, we can read the link information from the test tool, and we can bring it together, but we can bring it together not only for two parts or two types of artifacts on a V, we can then build up the whole V, and analyze the traceability as a whole. Yeah, and we have really, once we have defined our vocabulary, we can define metrics based on that vocabulary. So let me just figure out whether this demo dashboard is up and running. Yeah, seems so. So here is a metric called project status over time, over periods of time. And here is a vocabulary. So a stakeholder requirement is new, or analyzed, or work in progress, or implemented. And it is new when it's not linked at all. That's what I know under the hood. So that's my vocabulary mapping. It's analyzed when it's linked to at least system requirement. And it's considered to be implemented if it's linked to the software unit, so the whole left leg of the V. And each other state in the mean is work in progress. So we have a metric based on vocabulary, and you can understand this metric easily without being a, let's say, graph expert or graph query expert. And yeah, you can extract the data. So here's a series of time. You can see the project status, how your project evolves over time. Yeah, and this is a typical solution that we built for our customer based on traceability data and completely fed by traceability data. Okay. Yeah. Of course, we have support impact analysis to let's say fix errors systematically, find the reason why does a test fail, and I will show that during the demo. Yeah, of course you can compare your whole V between different points in time. So you can run our tool on a command line basis on Jenkins, and it extracts all the data, it creates a dashboard, and you also can create a Delta report and compare the data between different points in time, and say we have let's say 1,000 new requirements, or this single attribute changes. If it happens that we have enough time, I can demo that in this webinar. Let's see how it works out. Yeah, and yeah, we support you to pass your assessment. So this story happened at customers really during a SPICE assessment. The assessor wanted to see one special analysis of traceability data, and this analysis or report that the assessor wanted to see was not part of the standard reporting in that company. And but with YAKINDU Traceability, we have a built-in query language, so they could just build the query, and the system gave the answer. Assessor was happy, and finally it ended up, after years of working together, we now have reached Automotive SPICE level 3 together with Costa. Yeah, and we have a project overview. We will see that in the demo. So it really gives you a good insight about how your project is set up, what is important in your project. I will demo that. So forget about the slide. Yeah. Then I want to talk about our process, how we introduce traceability into a project or an organization. Usually, I would not add this slide to a webinar like this, but due to the complexity, we recently changed our process, and I want to highlight that. So first of all, we get to know each other. So we demo what YAKINDU Traceability is, and you explain to us your world, your problems, which tools do you use, and where are your problems, but then step 3, so this has changed, and I want to highlight that. Together, we decide what fits best for you. So we don't say take our tool and you'll get happy and we help you customize it. We say consider our YAKINDU Traceability as a palette of tools that may help you, and together we decide which parts are suitable for you, which parts are helpful. Shall we do a dedicated? Shall we develop a dedicated traceability solution for you, or is the off-the-shelf tool helpful for you? So we've seen this slide with this complexity, project complexity in the field of autonomous driving, and off-the-shelf tools cannot cope with these complexities. So we have to build individual solutions, and yeah, we are open for that. And if you want to develop your own individual solution, we can bring in our bits and pieces and building blocks and our experience. So we know your first change requests already to help you set up really a traceability solution that helps you and your engineers. So now on to the live demo. Let me just switch to YAKINDU Traceability. So this is a welcome screen. I said I had this on the slide. You can get a fast overview. And we have this view called YAKINDU Project Overview. And you see what is configured here. So we have a configuration of a typical automotive SPICE V. And I've read here in this scenario 15 stakeholder requirements from doors and interface specification. In Excel, software requirements are read from doors. We have a software architecture from Enterprise Architect, detailed design in MATLAB, C code, unit tests, of course, VectorCast and the results, and on the right-hand side of the V, some XML files and some Office documents. So first view is really the configuration. You see how is your project organized, and you can see directly, let's say, which requirements do we have. So we have 16 software requirements. Here they are. You can overview them. You can filter them, and you can directly navigate to the tool. So if I double-click this guy, Doors opens up and brings you directly to the requirement. So navigation to all these tools is supported, and that's really traceability. So you can follow the trace to Doors, or you can follow the trace to Enterprise Architect or to Excel. So really traceability literally is here implemented. Another thing that I want to draw your attention to is you see this link from software requirements to unit test spec. That's a typical situation that we see. So the unit test tool is linked to software requirement, and VectorCast is also linked to software requirements. But this is not automotive SPICE compliant. So we really had scenarios where the SPICE assessor said detailed design. Unit tests should be specified based on detailed design. With YAKINDU Traceability, you can derive these configurations. So if the very same software requirement is linked to a unit test directly and indirectly to a model element of your detailed design, then they belong together. You can simply specify a rule in YAKINDU Traceability, derive the link, and the assessor is happy. And to us, it does not matter whether this relation is visualized in a report or really in a drawn graph or whatsoever. So that's our approach. So once we have the data aggregated and related, we can do smart analysis and prove that you are SPICE compliant, even if your link is not, or if your linkage is not 100% SPICE compliant, or whatever process standard you need to support. Second thing that we can see here, we can really look at the rules, how the links are derived. So I mentioned already that let's say software requirements and unit tests, they are linked in the unit test tool, so you don't have to maintain these links manually. So if I click on this guy, I can really look at the mapping rule. So yes, we read from VectorCast the attribute test requirement key, and when the test requirement key contains the ID of the requirement, then we consider this as a match and as a link. So you can really specify smart link or relation derivation rules, and we support that. Another thing, you can just toggle the coverage matrix here. So here I see that 2/3 of the system requirements have an outlink to the qualification test, and 85% of the qualification tests have an inlink from system requirement. So yeah, not such a good coverage, so some work to do here, but you can see at least there is some work to do and what is the status. And if we want to see which requirements are not linked, you simply can click on this guy, and you see here in the query result that these requirements are not yet linked, and these requirements are already linked to tests. So we really put you in a position where you can analyze your VF fast, you see the gaps, and where is something wrong. Yeah, to figure out what is wrong when we look at the unit test results read from VectorCast, and if I open up this guy, you see there are some tests failing at this point in time. And now I want to analyze which part of software is affected, so that I can fix the software so that the test is passed. But before I do that, I pass over the presentation to Ingo Niklas, so that he can explain to you more details about VectorCast, and why VectorCast comes to the conclusion that my software has bugs.
Yeah, thank you, Boris. Hello, everyone. My name is Ingo Niklas. I'm Field Application Engineer at Vector, and I'm specifically responsible for VectorCast. I do VectorCast support for about 7 years now, so I should know the tool pretty well. I do not necessarily know all other vector tools, but I'm good at VectorCast. And I want to show you in just 10 minutes a little bit of unit testing, mainly unit testing, and how you can test your software, specific functions or C files using VectorCast, and also how we integrate, for example, with YAKINDU, and what artifacts from VectorCast YAKINDU uses to build the links to create these traceability informations. VectorCast can not only be used to create unit tests, we also have a functionality to measure code coverage from unit tests, from software integration level testing, or even from system level testing. But I will not focus on the coverage part. I will focus on the unit tests. So here we see a test project, a project that has multiple test environments, unit test environments, and software integration test environments. Each of these test environments tests, for example, one C file and all the functions in that C file, and all these test environments are independent from each other. So we can build these test environments, run test cases on the code independent from other files, from other implementations. And if you wonder where these unit tests come from, we can create a new unit test environment. And the benefit of this project is we can use the project settings, we can use the compiler configuration, the linker configuration, the include paths. They are all the same more or less for all files in the project. So when we create a new environment, we can just inherit these settings from the upper nodes. So the wizard that opens, that allows us to create the unit test environment, a new one from scratch, already knows what's the compiler that we want to use. For this demo, we use a native compiler. We use the Visual Studio compiler for C. But as you can see, if you would start in your own test environment, you may have an embedded compiler, you may have something like Green Hills or IAR or, I don't know, Kyle compiler. And then we prepared some templates that you can use to create a unit test executable. All we need to know in the wizard is we need to know a name. So let's say this is any name for a new unit test environment. And then in step number 6, we can decide what is the C file that we want to test. And as an example, I want to test state machine CY. We can also determine or set up how do we want to handle stubs, because stubs are very important in unit testing. One of the benefits, one of the major key aspects in unit testing is that you stub all dependencies, all functions that are implemented outside. They are stubbed so that you have control over what the stub does, what the called functions return, for example, and we can verify parameters that are passed to those call functions and really focus on the code under test and not on the dependent functions. So usually you would stub everything, but with VectorCast we can, for example, customize this process. We can ask VectorCast to analyze the call hierarchy of the functions in the C file, and then we see which dependent units do exist. So this unit is the one we want to test, state machine CY, and it has dependencies to all these C files. That means it calls functions that are implemented in these C files. By default, we stub this, so the stub will not call the real implementation. So the real implementation will not call the dependent functions. But if we say we don't want to stub, we want to call the real dependent function, then we can determine in different levels whether or not we want to stub or not stub or use the real code. So like this, you can set up your test environment and you can say, I want to stub or I don't want to stub. So for this example, we will stub everything that is implemented outside and then just build the unit test executable. So this now creates, as I said, a unit test executable that allows you to execute dynamically tests on specific functions. For example, we can create a test case on this function. One test case is a call to a function, so you have access to the interface of the function. So this is the function name, and these are the parameters that are passed to the function. And for the purpose of a test case, you can, for example, set global variables to some specific predefined values. Then let's say we call the function with some specific values, and then we can also enter expected values. We can, for example, expect that the function returns 0, and we also have access to the stubs. We can ask the stubs to verify parameters. For example, we can check when the stub is called, will it get the proper parameter passed? And we can also tell the stubs to return specific values, whatever we want for our testing. So where do these expected values come from? Usually you would get them from requirements. And with VectorCast, we can import requirements into the unit test tool. And at the bottom, we see a list of requirements that we imported into the test tool. This has two advantages. One of them is we can look at the description of the requirements so that we know what are expected values. And then we can link the requirements that this test case verifies. We can link them to the test case. And with this linkage, YAKINDU can do the traceability. Of course, we do have some reports in VectorCast too. We have some reports that show which test case is linked to which requirement. But YAKINDU has the bigger picture. So once we created our test case, we can dynamically execute the code. We see that the result of the test case execution is a pass. We see that we called the function under test. We called the stub. The stub checked a parameter that was passed and it matched our expectations. And then we also checked the return value of the function. And so everything is fine. We do measure code coverage. Also in unit testing, so we see which lines of code were executed or not executed. if you would have to measure MCDC coverage, then we can even help you with MCDC tables, truth table that can show you which test cases would you need to create, or which parts of your decision points would you have to execute with true and or false to get 100% MCDC coverage. And we could even automatically create test cases, but that's a different story that we don't want to talk about now. So we linked the test case to a requirement, and for this purpose we had to import the requirements into the tool. And this is done using our requirements gateway that we have in VectorCast. And for this demo, we used the CSV profile. So we imported the requirements from CSV because we do not have access to ITEMIS DORT. That's why they've extracted the requirements for us in a CSV file and sent them by email. But if you had access in your local network to any of those tools, then you can also integrate with them and import requirements into your test tool using this integration. We have a list of imported requirements, of course, and then in the end, we can also export the requirements back, for example, into your requirements management tool, or for the traceability in YAKINDU, we exported the results back into a CSV file. And we only export test cases that are linked to requirements, and we so you are free to decide what should be exported and how should it be exported in case of CSV, because we don't know how exactly you want the format to be exported. For YAKINDU, when I press the export, then we said we want to have a list. So let me just find the editor. We export a CSV file where we have the name of the test case and then the result of the execution. And this can be read by YAKINDU so that they know which test case passed or which test case failed. And also what they can read is the test case definition, where we store the linkage between test case and requirement. And we see this when we get out of the unit test tool back to the manage project. Then we can look at the way we store test case data, and we find the test case data in a folder with the name of the project. There is one folder called environment, and this one folder should go to version control because it has all testing data, even the environment setup, what should be stopped, what should not be stopped, what's the C file that we want to test. All this information is stored in one folder per test environment, and the test data specifically is stored in the TST file. So that was the wrong file. I wanted to open the one for UUT AnyName. In this TST file, we have the one test case that we just created, and we see that this TST file has information. So first, of course, what's the name of the test case? This is an information that YAKINDU finds in the CSV file again. And then we have the linkage to the requirements, which is the requirements ID. That's why they know which test case is linked to which requirement. And they even can tell what's the function that the test case is created against. So if requirements change, I'm pretty sure that YAKINDU can give you a list of functions that are affected by this requirements change. Not only the test cases, but also which C files and which functions. Okay, so the last thing I wanted to show is how we can create or how we can run the test cases. And since this can be a huge number of unit test environments, it is very beneficial that we have an incremental rebuild. We can incrementally rerun and rebuild all test environments. And this is pretty quick. And because we did not change anything, we did not change any source code, and we did not change any test cases. And this can, of course, also be done from the command line interface. And to do that, we just need to call our tool manage. Just need to find the correct folder. And then we need to tell manage what's the name of the project, which is Y per washer. And we need to tell manage what do we want to do. And we want to build execute. And we want to do this incrementally so that it is quick and just do what needs to be done. Incremental. So then we get instant feedback. We hope that nothing needed to be done because no source code changed, no test case changed. But if anything changed, or if we want to do the full rebuild, then we can also do this from command line. And so this can perfectly be done from continuous integration servers, for example, or it can be done from YAKINDU in case source code changes. And so this is something that I hope Boris will show us right now. So I would like to pass back to Boris. Thank you.
Yeah, thank you, Ingo. So you said YAKINDU has a bigger picture. So let me just demo this picture. So I'm switching from the configuration to the tracing view. So here you have a tree view where all the artifacts are displayed that we've read from the various tools. And I just want to demo the navigation. So here are some MATLAB blocks, and once I double click it, this built-in MATLAB viewer pops up. And I can navigate directly to the block. And if you're familiar with MATLAB, you're probably asking what this propeller icon is. So this is a decoration from YAKINDU Traceability, and you can directly navigate, in this case, from the MATLAB block, let's say, to the corresponding model element of your software model in Enterprise Architect. And we've seen the navigation from YAKINDU to the various engineering tools, and it also works in the opposite direction. So if I now click the artifacts in the Enterprise Architect, the selection is reflected back to YAKINDU. And if I put the focus on this overview, which visualizes the traceability, and you can directly experience the linkage of the selected artifact in Enterprise Architect. And with the help of YAKINDU Traceability, you could navigate from this software architecture element to the belonging stakeholder requirement endorsed just by a double click. So we really bring the tools together. So that was traceability, bringing tools together, closing gaps, closing tool gaps. We've seen that we have 2 failing tests, and I want to see what happens. So I prepared a validation which just analyzes the status, and there are quite a lot of issues. So we see that some tests are failing, but we also see that this stakeholder requirement has an unverified software requirement. So if you need to report your project status based on stakeholder requirements implementation, you can do this with YAKINDU Traceability. So really, a unit test fails, and you can get the list of affected stakeholder requirements from the tool. So that's let's say really good reporting support, and you see what happens where it kicks in. And this is just a small example. So, but imagine you had really thousands of requirements, and you want to see which of them are wrong and why are they wrong. So this stakeholder requirement has this red X. So something is wrong here because this software requirement has a failing test. So you can really follow the trace back of this failing test to the stakeholder requirement. So through the whole V. That's really a reporting support, and you can have it in a tool or in a dedicated report. You can run YAKINDU Traceability, of course, in command line modus and get your report via email or download it via web. So that's built-in standard functionality. So now I'm switching my hat from, let's say, stakeholder requirements responsible to software developer. My boss just told me some tests are failing, and I want to figure out which portion of source code is affected. So I'm switching to the analysis perspective, and yeah, I prepared some queries. So and one query I called it task list. So it's called stakeholder software requirements with failing tests, and I even implemented an impact metric. So this failing test has a higher impact than this one, because if I click this guy and here is the failing test, it is only linked to one software requirement, and this failing test is linked to 2 software requirements. So if I want to get my metrics as green as possible, I should fix this test first. And this demo has been inspired really by customer requests and solutions that we implemented for them. So this is a real life scenario. So I know this test is failing. 2 requirements are fracted, and I can even see which C file is wrong. So if I double click this guy, the C files opens up, and I know something is wrong here. And yeah, as a skilled developer, I can see here is the bug. This 900 should be 1000. So I made a mistake. I saved the file. I connected my environment to VectorCast. So with a simple build command, I trigger now the VectorCast incremental build. This would usually happen probably on your Jenkins, but the developer has a choice to do it also on his machine. So yeah, my computer is not as fast as Ingo's, so give it some time. So now we are through, and if we go back to the analysis perspective, and if I run the query again, I see, oh, there's only one test, one failing test. So I fixed this test based on traceability data, and I could implement really yeah, impact or fix order algorithm based on the data that we read from the V. So yeah, the message that I want to give to you is really we can do smart analysis of your linked data, and that's beyond plain traceability as it is required by standards. So we really can work with the data, and it's a treasure of data, and with YAKINDU Traceability you can use this treasure easily. So yeah, that is my final message before passing over to Winfried for the Q&A session.
Yes, thank you, Boris. As Boris said, it's already time for the Q&A session. To all participants, please feel free to send us your questions you will probably have. Please use the Q&A window and send your questions to the moderator. I would like to start with you, Ingo, because Boris just ended to speak. Do you have any questions you can answer, Ingo?
Yeah, there are quite a few questions, so thank you for asking. One of or 2 questions are regarding the requirements gateway. We saw that requirements are imported from a CSV file, and there was a question, what does the integration look like for Polarion? And there was another question, whether or not we do support DOORS next generation and what that looks like. So yes, we do support DOORS next generation and also Polarion. And if you integrate with other requirements management tools, then it depends very much on what we do depends on the capabilities of the tool. So for example, with Polarion, I know that we create new work items for each test case. If you export the data from the unit test tool to Polarion, then we create for each test case, as I said, a new work item, and we link it to the linked requirements so that you also get the traceability in the requirements management tool. Then there was a question on code coverage in system testing. How does that work? Well, we measure code coverage using source code instrumentation. That means we add additional code lines into the code that set bits in memory so that we know which line of code was executed or not executed. And we can do this on your source code on all your source files, and then you can use these instrumented versions of the source code and build your system test application either in a pill mode or software in the loop mode, or you can run on the real hardware, and then we can get coverage from that system. Then there is a question on MCDC coverage from GCC ARM. Yeah, of course, the coverage measurement also works on embedded devices, and we also do support the GNU compiler family, for example, GCC ARM. And there is also a question on Linux, which, yes, we have a VectorCast version for Linux and for Windows. So that's, I think, the questions that I found for me, but I see that there are a couple of questions for YAKINDU. So over to you, Boris.
Okay, dankeschön. Yeah, first question. Yeah, can requirements be created starting from the design tool? Clear yes and no. So in the off-the-shelf tool, this is not possible. So in the off-the-shelf box product, we just bring the data together and relate them, but we do not manipulate them. But we build custom solution customizations for several customers where you can edit these extracted data, and these edits are then reflected back to the original tools. And it does not matter if this is a requirements or modeling tool. So we created on this way, let's say, yeah, cross-tool edit possibilities for your data based on YAKINDU traceability. So yeah, but let's say our core is we are traceability product and not an editing product. But if you need something, an adjustment which improves your process, which makes your life easier, then we can yeah, contribute to that. Another remark based on the answer that you just gave, Ingo, to Polarion. So you said that you are creating work items in Polarion based on test cases that are created in VectorCast. With YAKINDU traceability, you don't need to do this because you are just creating data redundancies, and we just want to link them. So just link the requirements, and we can analyze traceability, and we can do it faster than the approach that you mentioned, I bet. Yeah. Next question. Is it possible to link requirements into Vector Da Vinci tooling or AR XML files? Short answer, yes, it is possible. So we have generic adapters for text and XML files, and with these adapters we can really get hold on a huge bunch of artifacts and file formats. We use this in customer scenarios and together in webinars. Also showed the ARA XML analysis of AutoSAR files. Yeah, so yes, simple answer, this is possible. Yeah, looking at the time, so one last question. How fast can you read data from DOS? Yeah, depends on your network infrastructure, provided you have, let's say, medium good bandwidth, then we can read like 10,000 requirements per minute, and given a good network performance, we can read 20,000 requirements per minute from DOS. Yeah, so pass over for the final words to Winfried.
Yes, thank you, Boris. We have to come to the end of this webinar about integrated traceability solutions for development of autonomous vehicles. Thanks again to Boris Holzer and Ingo Niklas for your presentations. I want to thank all attendees for your interest and the time you spent with us. I hope you enjoyed this webinar, and we can welcome you again at one of our next webinars. Don't miss to visit Vector at the Embedded World in Nuremberg next week. I wish you all a great day and a successful week. Goodbye.